All right, let's take a look at design and architecture. So again, in troubleshooting and admitting the system, it's always important to understand how the system is designed, how it's supposed to work, to know the as-built, so that when you know it's not working or think it's not working, you understand how it's supposed to work. So design and architecture is what we're going to cover now. So on most ShoreTel systems, you have a headquarters server, the HQ, which is sort of the brains of the system, where we'll take a look at it. It supports your Connect director. It's also your voicemail server. It manages work groups. It also manages or is a place where you can record your auto tenants. It's also where the ShoreTel Connect client registers to. And lastly, it is where the soft phones register. So the one thing to keep in mind, especially with this last one, soft phones, there's different functionalities in each piece of these. So for instance, the Connect director runs off the HQ. The voicemail server can be on the HQ, can be other locations as well. Work groups can reside on the HQ or be distributed amongst other DVS systems or distributed work groups. The auto tenants, if you ever configure an auto tenant, you realize that there is no location that you assigned it to. So the auto tenants are all configured on the HQ, and then they get actually distributed to the rest of the voicemail appliances. ShoreTel Connect client, it is the initial point of the registration of the phone, which means, of the client. So when the client first connects, it registers to the HQ, and the HQ will say, oh, by the way, you belong to this site with this IP address range and this DVS server. So now re-register to that local DVS. So you can actually have your Connect client register to the HQ, or if it belongs to another location that has a DVS, it can re-register itself on that local DVS. So therefore, it's not connecting across the wide area network to register. And the soft phones only work on the HQ. So if you have soft phone users and you take down the HQ server, you are literally going to take down those soft phones. And the limitation here is only one HQ per server. Only one HQ per system. Now you also have the DVS server. Now the DVS server is a subset of functions from the HQ. So it does things like, it's also a voicemail server. It also can handle work groups. It also a place that houses auto tenants. You can't configure it on them, but it also houses the auto tenants. ShoreTel Connect client is the one that registers to it as well. And you have a maximum of 20 DVS servers per system. And the reason why you'd have a DVS is a couple reasons. Number one, you can offload a lot of the functionalities we talked about before, voicemail, auto tenant, all that sort of stuff, onto a DVS, so that your headquarters server is just doing sort of administrative tasks and there's really no load on that box. Or if you have a remote location, I'd say somewhere between, roughly put about 80 users, 50 to 80 users and above. If you wanted to keep their voicemail traffic and their connectivity across your wide area network down, you would give them the local DVS server, and that way it could keep all the traffic on their premise and not going across your wide area network. And I didn't mention, but what happens is there's a maximum of 20 DVS servers per system. So when you look at the total number of servers per ShoreTel system, 20 in the DVS and 1 for the HQ is a maximum of 21. If you don't already know this, you can do 500 IP switches per system and theoretically support up to 20,000 users on the system. Now I talk about the V switches, the 90V and the 50V. It's a voicemail server, and it's configured to do 50 mailboxes and 90 mailboxes respectively. So it is a off-site voicemail, and again, it's one of those places where if you have an office that has 10 or 15 or 20 users and you don't really want their traffic, or maybe their wide area connection is not the greatest, you want them to stay local to do their voicemail, you give them a 90 or 50V switch. You'd rarely see these at the headquarters, only if you'd sort of repurposed one of the remote sites back into the headquarters for additional. But I rarely, if anything, have seen a V switch at the headquarters to provide voicemail services. It's really for remote offices. Auto tenants, as I mentioned before, when you set up the auto tenant on the headquarters, it actually distributes those voicemails and the auto tenant messages to all the V switches and all the voicemail servers. Now, if you are familiar with or don't know, the way that ShoreTel sends voicemails to each of them, the voicemail servers, is through SMTP. So it emails them and proxies through the HQ server and direct connect so that these things email back and forth. So if you're not getting messages that are being updated at your remote location on your vSwitch, or you just upgraded the auto tenant, you change the auto tenant message and you call into one of the remote locations and it's not actually recording, you don't hear the new recording, it's probably because it failed to send SMTP through SMTP reach that device, which is typically something on your network that is blocking it. And you have a total of 100 vSwitches per system. So technically you can do 121 voicemails on ShoreTel. Now the next part we're going to look at is how ShoreTel makes calls and how it works over your LAN, WAN, and out the PSTN. All right, we're going to take a look at how ShoreTel makes calls. So first off, start off with a phone here, which is extension 100, and it's on a 192.168.1.199. So what we're going to talk about now is the user at 100 wants to call 101, and for this demonstration, we're actually going to have them registered over 2 switches. So it would be much easier if it was over 1, but just to show you how it communicates. So first thing we're going to take a look at is, so user 101 dials an internal extension 101. The phone actually contacts the managing ShoreGear appliance, the one that's registered to. It says, hey, I need to call extension 101. Where's he located? The managing switch tells the phone that 101 is located at 192.168.1.50. So this is on the same network subnet, which is great because now it's just going to go over your local area network. So it's going to be a broadcast to find this address and this MAC address. It's not actually going through any routes or have to go through a router. Then what happens is the managing switch signals the other phone's managing switch. It says, hey, by the way, I need to ring your phone and I'm going to send you a ring signal. And the managing switch then sends the ring to extension 100. Now, if you've heard this and the phone is ringing, it is not a voice call. Although this might be on your voice VLAN, it is still a data call. That's why you can have your phone ring and you hear it and you pick up the phone and there's no audio because it is just a data call at this point. And once extension 101 picks up that call, there becomes a point-to-point RTP stream between the 2 locations. So at this point, I can now take this switch off and take this switch off and unplug them, and these 2 phones will stay up on a call because it's a point-to-point RTP stream between those 2 extensions. This is how it works, but what these switches are doing is they're involved in the call setup, which is the signals we just did here, and then if one of these users hangs up, the reverse happens, and they send these signals and start disconnecting. So the switches, the ShoreGear appliances, only are involved in the call setup and the call teardown. So that's why it can, I literally say, you can actually disconnect this and unplug this from the network. And that's why also if someone is on an active call and you reboot a ShoreGear appliance, it's not actually going to drop that call. Now keep in mind, if it's a T1 or a trunk switch, you'll drop those calls. But if they're just users on the switch and you reboot it, it is not going to cause that call to drop because it still has a point-to-point connection. Now, how does it go over to the PSTN? Same thing happens. When a user dials 9 plus the number or their access code plus the number, it sends a message to the managing switch, says, hey, this person wants to make a trunk call. And then it's going to go through and it's going to say, okay, based on, your information, here's the IP address of the switch you need to go out. So in this process, there's going to be this algorithm of, hey, who's the user? What number are they dialing? Do they have access to those trunks? Do I want to give them access to those trunks? And can they make that call? Yes, allow call. So as soon as everything is going, that this person has access to go at that trunk, it's going to send a signal to the managing trunk switch, the T1K at 1.10 and say, hey, we're about to make a call to you. And then what happens is the user phone takes a RTP session to the actual phone appliance, the trunk appliance, and that appliance will actually send that call out to the telco. So back in our previous slide, I said I can take this switch out and unplug it, power it, recycle it because it's not going to affect the call. Same thing's going to happen here. This call will stay pinned up if I reboot this switch. If I reboot this one, call drops because it's involved in call. It's involved in the active connection to the telco. This one was involved in call setup and teardown. So that's how that works. Now, how does it work over the wide area network? So it works similar to the way it works on the LAN, except it's going to default to your network and your network routes. So for instance, 1.99 wants to reach 2.50, different subnet. So all what happens here is it actually sends that extension to the managing switch, says, okay, get this information on 101, and it basically says, hey, here it is on a different subnet. At this point, this extension, when it's actually going to go make that call and it's going to set up that RTP, it's going to have to route across your network and figure out a way how to get to 2.50. Okay, if that route is not there or that network is not there, it's going to still try and place that call, but it's not going to be able to make it there, and you're going to get one-way audio. So what happens is you'll send the managing switch the signal that 101 is going to call, or it's going to call 101, and it's going to ring that phone, and then it's going to send that call, that RTP, across that wide area network. And again, this part here, the RTP, is all leveraging your routing and your wide area network and your network routes. So all it knows is, hey, this call is not on this network. Send it to the router or the default gateway that needs to get me to the other location. One of the biggest things that we've seen that happens quite a lot is anytime you go in and change your provider and change your default gateway. So for instance, you're with provider 1 and you want to go to provider 2, and you decide that, you know what, instead of swapping everything out and keeping the IP address the same, we're going to change our router to a .254 versus the .1. Or we're going to change it from a .1 to a .2. Well, what we have to keep in mind is engage us, because your DHCP is going to have to tell your phones that the default gateway has changed. Your appliances are going to need to know that the default gateways have changed. So if you are changing your network and your default routes and your default routers and your default gateways, the ShoreTel has to be updated. So if you are going to do that, either reach out to us and get some guidance and help us change it, or make sure you've got that all set up before you actually make that change. And the next piece we're going to talk about is the voicemail failover and how it's built in ShoreTel. Now let's take a look at voicemail failover and redundancy in the ShoreTel. In the ShoreTel voicemail scenario, you have 3 levels of voicemail that you can set up. Now, most customers, I'd say, usually have it sort of 2 tiers, and then in the odd occasion you might have a 3rd tier, a child of a child, because ShoreTel works in a parent-child situation. So this would be the parent, child, and this would sort of be the grandchild, or that would be the parent of this one. So you got a headquarters server that has your main voicemail. You could have a DVS, which could reside at the headquarters at a remote site, and then you have the remote site that might have a vSwitch, or a DVS if it's a larger remote site. So the first thing you want to do is, if actually a call comes in and that voicemail goes down, so I'm a user that's assigned to this location, and my voicemail goes down, the call comes in and it gets routed over to my parent. So my parent site, which might be this remote site, which has a DVS. And what that does is it actually, when you first create a mailbox on the headquarters server or any one of these locations, it'll actually send that copy of that mailbox to each one of the voicemail servers in the scenario. So headquarters will have a copy of this extension, this one will have a copy of this extension, and this one will be the primary. Now the 2 copies in the remote headquarters are just the voice recording. So, it'll say Ken's Roebuck is not available. It's not going to have your voicemail greeting, the full message. This is stored down here. So if a call comes in and your voicemail goes down, it'll actually fail up to the remote site, the parent, and it will do what's called store and forward. It's going to store those voicemails and forward it back to your original once it actually comes back up online. But let's say that you had some catastrophic event and your second voicemail went down. That call will actually bounce up to the parent site. So in ShoreTel, you can actually have your voicemail go up 2 levels. So it can go to the primary, so it can go to the parent and the grandparent, and that's it. Now again, one of these things is going to happen is that it's only going to do a store and forward. So when I'm down and my primary voicemail is down, I go to check voicemail on my phone. It's not going to proxy over to these other sites to check my voicemails. It's going to still try to check at this location because that's where it's assigned to. But what happens is if this voicemail server comes back online, these 2 boxes are going to forward it back to the home user's switch. And then once my voicemail comes back up, I will then be able to check my voicemails and listen to it from here. But what it does, just so you understand, is when it has your primary voicemails down, it will forward that to another location that will play your recorded greeting and take messages. So I can't use it in my communicator to listen to my messages. I can't check my phone from my voicemail and press the voicemail button. It is just going to store and forward. So when this primary voicemail comes up or you move the user to another location that is working, those voicemails will get forwarded. Now, if you do that and they're on this primary voicemail down here and that's offline, nothing is being forwarded till that comes back online. And that's how voicemail works, 2 levels in ShoreTel. Next thing we want to talk about is work groups versus hunt groups. What are they? Why do they matter? What is different about them? And when should you use them? So work group versus hunt group. A work group resides on the server. So it resides on one of the DVS servers or the headquarters server. And because it does some more sophisticated or higher level of call routing, some algorithms it needs to determine before routing calls, like who's the least idle, who's the most busy, what group it belongs to, are they logged in and logged out. Whereas the hunt group resides on the switch or the ShoreGear appliance. And the hunt group is a poor replacement for a work group, and it has limited call queuing capabilities. So you can actually have it reside on the hunt group so that you can have things like, call distribution or ring groups where you want to ring 10 or 8 or 10 or 12 phones at the same time. That's all being powered from the hunt group itself. So the work group has call queuing capabilities, not as sophisticated as the contact center, but it does have call queuing capabilities up to 5 levels, and you can offer custom call routing, each one of them, and music on hold and thresholds. And the hunt group has rudimentary call queuing capabilities. All right, and the work group is often a backup for route points in the contact center, the enterprise contact center. And what we use the hunt group is a backup for work groups. So in a contact center, we can actually have the contact center route points being backed up to work groups and the work groups backed up to hunt groups, so that you can actually have sort of 2 levels, if it's not a redundant contact center, 2 levels of failover, so calls will still get routed to agents. Obviously, if it's routing to a work group versus a hunt group or from the contact center, you're not going to get the same level of call reporting, but calls are still being answered, and that's the key point. It's usually somewhere between 250 and 300 agents. With a hunt group, you can have between 16 and I put there 24 members per switch, because one of the things with the new appliances is that you can have some additional capabilities based on that because of the enhanced sort of processing power in the CPU that's on those boxes. So you can have up to 24 members.